I hope everybody is trying to understand the figure. If you understand through, I can explain it easily. Okay, I hope you have completed. So you can see here, so the first thing you should be clear that whenever you are using the water softening method, that is being used before the filtration. Yes, anybody want to ask question? Okay, whenever you are using the Jollite method as a water softening method, that can be used before the filtration process. Okay, so here in this figure you can see clearly the raw water or which we want to treat is being applied from the top, and in the raw water itself the chemical, that is lime and soda together, is being added over here through this port. Okay, and so that water will be reacting with each other. Water and the lime soda, the reaction will be performed in the reaction tank. This is shown over here, and from that it will be slowly allowed to drop down through the conical end. Is it? When it is dropping down, at that time the solid particles, that is precipitate, whatever the sludge formed, flux formed, it will be dropping down, and the clear water will come to the upper surface, and from the top layer the water, the pure water free from the hardness, will be forwarded for the further treatment process, and the dropped precipitate or the calcium carbonate and magnesium hydroxide precipitate will be removed from the bottom, and then that softened water will be forwarded for the filtration process. So filtration process in detail you have studied already. So I will not talk much about this part. So I hope you are understanding. Chemical reaction, chemicals are added in a water, and the time is being provided for the chemical reactions. And the arrangements are made such a way that easily the sedimentation can be performed here, because we have already done the sedimentation process in a sedimentation tank, but that is for the individual particle settling, as well as those are possible to get coagulate with the help of coagulants, but those are not possible to get coagulate. Those are in a dissolved form. For that purpose, we need to apply the such types of methods. That is, one among is the lime and soda together application. So here we have provided reaction time in a reaction tank, and when it is slowly falling down, obviously the solid particle will settle down at the bottom, fall down at the bottom, and can be removed from the bottom. And the clean water will rise up, and that can be removed from the top. जर हे आउटलेट इथं काढायच्या ऐवजी इथं काढलं असतं तर काय झालं असतं, इथं काढलं असतं आउटलेट तर काय झालं असतं, हा जो प्रेसिपिटेट आहे, some quantity of precipitate may get flowed with the water, पण इथं ग्रॅव्हिटीच्या अगेन्स्ट होतोय त्याला फ्लोला, त्या प्रेसिपिटेटला अपराइज व्हायला, so it will not be possible to rise up, only the water particle will rise up, and hence the outlet is provided like this. So this kind of design factors you should understand while understanding the technique. Okay, so this is about the Jollite method, lime soda process. Okay, I hope you have understood. I will go to the next point. And I hope you have completed the figure also. So the usual method for lime soda processing is the treatment by excessive lime amount. Then pH should be greater than 9 for sedimentation of the magnesium hydroxide. Obviously, तुम्ही lime add करताय म्हणजे त्याचा pH rise upच होतो. Then usually pH is in between 10 to 10.5. The process contains lime dosing. A small amount of alum or sodium aluminate is added to ensure good sedimentation. Alum काय करतो? Alum is bringing the multiple small particles together. Agglomeration process होती. So that's why we can add some amount of alum or sodium aluminate. Sodium aluminate is also another coagulant. Is added to ensure the good sedimentation. The number of small particles together आले तर ते heavy होऊन जातात आणि heavy झाले तर ते bottomला settle होतात. So that's why we go for addition of some kind of some amount of alum as well as sodium aluminate in during the process of lime soda. Then the recycling of some sediment sludge can also help to sediment. म्हणजे कधी कधी पार्टिकल्स क्लॉगिंग होत नसेल तर त्या स्लजला रिसायकल केलं जातं, but again it is risky, so we don't prefer usually, but in some of the cases we can go to prefer that also. Okay, so this is the, now we will see what are the disadvantages. If the water contains excessive alkalinity after the softening process has been completed, there is a possibility that the calcium carbonate will settle in the pipes. What happens actually, if the water contains excessive alkalinity after softening process has been completed, there is a possibility that the calcium carbonate will settle in pipes. म्हणजे कॅल्शियम कार्बोनेट चे प्रेसिपिटेट फॉर्म होण्याची रिएक्शन जर कंप्लीट नाही झालेली असेल आणि एक्सेस अल्कलिनिटी शिल्लक राहिलेली असेल त्या लाईम सोडा मेथडच्या नंतर, तर that reaction may get complete during the pipeline. आणि म्हणजे पाईपलाईन म्हणजे कधी की पब्लिकला वॉटर सप्लाय करत असताना, and when it is getting completed during the pipeline, at that time there is a possibility to form possibility of formation of calcium carbonate. आणि मग जर कॅल्शियम कार्बोनेट पाईप मध्ये फॉर्म झाला तर तो सेडिमेंट होतो पाईप मध्ये, आणि पाईप मध्ये जर तसा सेडिमेंट होत राहिला तर पाईप ब्लॉक, वॉटर सप्लायची पाईपलाईन ब्लॉक होण्याचे चान्सेस जास्त असतात. So that is one of the biggest disadvantage with respect to that. But if we take proper care at the plant itself, it can be avoided. Then the softened water need to treat with H2SO4 or CO2 to remove this from the softened water. Need to treat with H2SO4 or CO2 to remove this from the softened water. This reaction is called a recarbonization. The carbon content वाढलेलं असतं water मध्ये. When you are applying some, is there anybody talking? Is there anybody talking? Okay. So when water softening process, we are performing it with the help of excess amount of lime. Definitely there is an increasing amount of carbon. So the recarbonation needs to be performed by applying the H2SO4 or we can apply the carbon dioxide for the recarbonation method. Okay, so this is about the lime soda process. Simply you can remember that lime soda process is a water softening method for hard water in which we can apply lime and soda together. Lime in the form of calcium hydroxide, that is CaOH2, or lime in the form of calcium oxide, that is CaO, and soda ash, that is Na2CO3. So when added into water, it will start reacting and converting calcium and magnesium into calcium carbonate and magnesium sulfate. And these are the precipitate can be settled down and the hardness of water will be removed from the water. कळालं का? वॉटरचा हार्डनेस आपल्याला रिमूव्ह करायचा आहे, जो फिल्ट्रेशन, सेडिमेंटेशन, कोॲग्युलेशन, एरिएशन कशानेच कमी होत नाही. ओके, so for that purpose we need to apply some effective and special treatments, and there are the different special treatments. One among that is the lime soda process. Demineralization method is the lime soda process. Got it? Got this point? Speak out, guys.
Yes, ma'am.
Okay, thank you. Shall we go for the another topic? Okay, now we will see a reverse osmosis. No. Before that, we will go for Zeolite process. We will go for the Zeolite method. Disturbing the class. Shubham Bhagwat, you are disturbing the class. Okay, now we will see the Zeolite method. Okay, now Zeolite method, whether Zeolite method PPT is displayed to you. Zeolite method PPTs are in display board. Zeolite process ची PPT दिसते का?
Yes, ma'am.
Yes,
Okay,
ma'am.
thank you. Yeah, thank you. Zeolite process. So what is this zeolite? Basically, you should understand what is the zeolite, and then we will understand zeolite process. Okay, zeolite is a hydrated sodium aluminosilicate. It is also known as the permutates, or it is also one type of sand. It is also one type of special type of sand, we can say. Zeolite is capable of exchanging reversibly its sodium ions for hardness producing ions in a water. And hence sometimes for zeolite method is also known as the ion exchange method. So what chemical structure of the zeolite is Na2O, Al2O3, XSiO2, YZH2O, YH2O, where X is equal to 2 minus 10 and Y is equal to 2 minus 6. In that much detail you need not go for. You simply remember that Na2O, Al2O3, SiO2, H2O is the formula of zeolite. Please note down. हा X, Y, Z काही लिहायची गरज नाही, फक्त तेवढंच लिहा. Na2O, Al2O3, SiO2, H2O. Please note down what is zeolite.
मॅम मागचं राईट नाही करायचं राहिलं. झालं मॅम.
Okay, good. Now, so what are the different types of zeolite? There are two types of zeolite. One is the natural zeolite. As I said, sometimes the special type of sand is also known as the zeolite. Natural zeolite are non-porous. For example, natrolite, that is Na2O, Al2O3, SiO2, and H2O form. And synthetic zeolite are also available in the market, and that synthetic zeolites are porous and possess gate structure. They are prepared by heating together china, clay, feldspar, and soda ash. These three components can be heated together and it can be formed the synthetic zeolite. Such zeolite possesses higher exchange capacity per unit weight than the natural zeolite. Okay, so what is the ultimate aim of this process is to have the exchange of ions, and that can be possible highly in a synthetic zeolite than the natural zeolite, because the porosity of synthetic zeolite is more as compared to the natural zeolite. Usually the natural zeolite is non-porous. Only at the surface the reaction of the uh, mm, reaction of ion exchange performs. But when we go for the synthetic zeolite, the reaction performs in a better manner. That's why we prefer to go for the synthetic zeolite. So what exactly happens? This can be observed in this figure. You can see this figure. Here is a closed container. This treatment is being performed in a closed container. Zeolites are provided as the packed structure over here in this. And when you want to treat the water, you can open this wall. I will use the anode. You can see, you can open this wall and allow to enter the hard water into this, and the hard water will pass through this layer or the media or this zeolite, the way we are passing the water in a sand during the filtration process. So same way the water will be passing, percolating through this, and when it is coming into contact with zeolite, the exchange of ions, means the calcium and magnesium will be absorbed by the zeolite, and the sodium will be released from that zeolite. Okay, and hence the calcium and magnesium is being removed from the hard water, and when the water is reaching at this spot, it will be soft water, and whatever the extra or the hard water remains still, that will be removed from the waistline. Okay, so this is the waistline. But usually during the zeolite process starting, means demineralization process starting with the zeolite method, at that time this wall and this wall will be open. So through this wall the hard water is entering and passing through this entire layer of the zeolite and coming into contact with the individual particle of zeolite. And during when it is coming into contact, because the zeolites are porous in nature, and they absorb, they adsorb, I am using that, it is a surface phenomena, they adsorb the calcium and magnesium and releasing the sodium ions. So exchange of ion is being performed over here, and hence that becomes a free from calcium and magnesium, and that can be removed, that can be that treated water or soft water can be collected through this wall. Okay, so this is the method of treatment. Now when this zeolite is being consumed for some times, at that time what happens, these zeolites become saturated, म्हणजे त्याची कॅपॅसिटी संपून जाते, की कॅल्शियम अँड मॅग्नेशियम ऍडसॉर्ब करायची कॅपॅसिटी संपून जाते, ते सॅच्युरेट होऊन जातात. मग सॅच्युरेट झाल्यानंतर वेन दिस स्टेज यू ऑब्झर्व, ऍट दॅट टाइम यू कॅन क्लोज दिस वॉल and start this wall through this brine water is coming. Brine water म्हणजे काय की NaCl solution. Regeneration method you can start. This method is known as the regeneration. रिजनरेशन कशाचं करायचं तर जिओलाइटचं, म्हणजे ते सॅच्युरेट झाले जिओलाइट म्हटल्यानंतर ते काढून फेकून नाही द्यायचे, त्याच जिओलाइट पार्टिकलचं रिजनरेशन करायचं. आणि रिजनरेशन करण्यासाठी आपण काय वापरतो तर ब्राईन सोल्युशन. ब्राईन सोल्युशन म्हणजे काय तर 10% to 20% NaCl solution. 10% to 20% NaCl you can apply into distilled water and prepare the brine solution. And through this wall you can allow to enter that brine solution and pass through this zeolite bed. When it is passing through this zeolite bed, each individual zeolite particle is coming into contact with this brine solution, and they are again releasing the carbon, calcium and magnesium, whatever adsorbed by them, and absorbing the sodium, that is Na, and that contaminated water will be removed through this waistline, So this process is known as the regeneration process, regeneration of zeolite. Once this regeneration performs completed, then again you can open the wall A. Time being I will say this is a, this is a B, this is a C, and this is a D. Then again you can open the wall A, but don't immediately open the wall B, because still there is a contaminated quantity of water is available. For some time keep open the wall D and let the water go out through this waistline. Then you close this wall and open the wall B. Then the process of treatment will start once again. Understood? कळालं का? Do you want me to explain once again?
No, ma'am.
Speak out, guys. Understood. Okay, thank you. Now please draw this figure. If anybody not understood, they can ask me. I will explain. No issue to repeat me again and again. So please draw this figure. Done, guys? Or I still want to wait? Someone has written message. Okay, Snail has written message. I hope everybody has completed. Or shall I wait for some message, some more message? I will give you 30 seconds. Okay, I received one more message. So we'll proceed. Thank you. Thank you, Priyanka. Thank you, Snehal, for replying. If you guys keep on replying, I can understand what is going on, or otherwise, only this is one way. Okay. So whatever I explained is written in the text. So we'll go through slide by slide. For softening of water by Jollite process, hard water is percolated at a specified rate through a bed of Jollite kept in a cylinder. That is what I explained. The hardness causing ions, that is Ca2 and Mg2, etc., are retained by the Jollite. म्हणजे ते adsorb करतात. And CaZe and MgZe, while outgoing water, contains sodium salts. Okay, sodium release करतात. So that is what reaction happens. Na2Ze, CaHCO through 3 twice, CaZe forms and NaHCO3 releasing. Okay. So same happens with magnesium and releasing MgZe. Okay. And when NaZe plus CaCl2 or CaSO4 reacts, then CaZe plus NaCl releasing. Okay. So that way, magnesium sulfate and calcium magnesium sulfate and calcium sulfate is removing from the zeolite, from the water in a zeolite method. Okay. So that is what represented in the reaction. Now the regeneration process, once getting contaminated and forms the it is getting saturated. At that time, we need to go for the regeneration process. So what is exactly happening in the regeneration method? After some time, zeolite is completely converted into calcium and magnesium zeolite. बरोबर आहे? त्याचा ताबा घेतलेला असतो त्या जिओलाइट मधल्या एनएचा ताबा कॅल्शियम आणि मॅग्नेशियमने घेतलेला असतो आणि म्हणून तो काय होतो की कॅल्शियम आणि मॅग्नेशियमनी सॅच्युरेट होतो and it causes the softened water. It ceases to soften water, that is gets exhausted. At this stage, the supply of hard water is stopped and the exhausted zeolite is reclaimed by treating the bed with a concentrated brine solution. It is 10% or maximum 20% we can use with the NaCl solution. NaCl. Okay. The washing, that is containing CaCl2 and MgCl2, are laid to drain, and then the regenerated zeolite beds thus obtained used again for softening process. So entire method in a soft language or the simple language I have explained while explaining the figure. Okay, so that is the regeneration method. Now limitations of this process we will understand. What are the different limitations of this process? If the supply of water is turbid, जे जर वॉटर रॉ वॉटर जर टर्बिड असेल, the suspended matter must be removed before it is applying to the zeolite method. Otherwise, the zeolites will get clogged with the turbid particle instead of the calcium and magnesium. म्हणजे dissolved method वापरतोय and instead of that clogged with this zeolite. So hence the turbidity must be removed before application of water to this zeolite process. Okay. So before the water is admitted to the zeolite bed, otherwise the turbidity will clog the pores of the zeolite bed, thereby making it inactive. जर ते ब्लॉक झाले टर्बिडिटीनं, तर त्याचं ते जे महत्त्वाचं काम आहे की removal of dissolved impurities in the form of calcium and magnesium will not be performed. Okay. If water contains large quantities of colored ions such as Mn2 and Fe2, they must be removed first because these ions produce manganese and iron zeolite, which cannot be easily regenerated. आयर्न आणि मॅंगनीज जर zeolite बरोबर रिॲक्ट झाले तर त्याचं रिजेनरेशन प्रोसेस होत नाही आणि एकदा का सॅच्युरेट झाले zeolite तर तुम्हाला ते कम्प्लिटली चेंज करावं लागतं. सो दॅट्स वाय if you want to remove such kinds of if you want to go for such kinds of treatment process, at that time you should apply the color removal treatment before it is going to the zeolite method. Okay. Then mineral acids, if present in water, destroy the zeolite bed. Therefore, they must be neutralized and soda before admitting the water to the zeolite softening method. So such types of impurity means primary and secondary treatment must be completed before we are going for the demineralization process. In simple language, I can tell you. Okay. Primary and secondary treatment must be completed before we go for the demineralization process by using any of the method, but especially for the zeolite. Now, what are the advantages of this process? It removes hardness almost completely, and water of about 10 ppm hardness is produced. आपल्याला 70-80 ppm पर्यंत हार्डनेस जरी राहिला तरी चालतो drinking water purpose साठी. But here in the zeolite method, it will be removed up to 10 ppm. Okay, the equipment used is compact, occupying a small space. No impurities are precipitated, so there is no danger of sludge formation. म्हणजे आपण बघितलं की लाईम सोडा मेथड मध्ये huge amount of sludge is going to be formed, and that has to be removed or by applying some specific treatment. And then the next thing, when you are removing, we need to treat that. Okay, so that is the another task being added into the treatment process. So, but that kind of problem is not being observed in a zeolite method. म्हणजे इथं sludges form होत नाही, simply regeneration process करावी लागते, बरोबर? So that can be removed. The process of automatically adjust itself for variation is hardness of incoming water. It is a quite clean. It requires less time for softening. It requires less skill for maintenance as well as for operation. So that's why this method is more effective than the zeolite method. So I request from this part, I request you to copy the